So R plus S is going to represent the union of the two sets of big R and big S. So when you write R plus S, this is a valid regular expression which represents the set of S string, which is the union of all the strings in big R, the one that those represented by little r, and those strings represented by little s. The concatenation of rs will be represented as just rs. This is going to be the concatenation of two sets R, big R and big S. R star is going to represent the set of all strings in R star or R closure. And this is not actually an operator, in fact, but this is more like a notation again. So parentheses are valid in regular expressions. Sometimes you might actually see brackets as well. So any kind of actually brackets is just used to to give the precedence. So just like in algebraic expressions, that for example, if you want to write a plus b, this is just a summation, a plus b multiplied by c, you cannot write it as a plus b multiplied by c, right? Because plus multiplication is going to have higher precedence. So you use the parentheses to put the to just make it unambiguous and make sure that you first add a to b first and then concatenate c. Here, over these operators, we do have some precedence levels. So the parenthesis is going to have the highest precedence, right? And after that, among the operators, closure has the highest precedence. After that, it's concatenation, and at the end, it's the union. So kind of you can think of it as, powers in algebraic notations and multiplication. So it's just like closure is just like the power. This one is like the multiplication. Concatenation is like multiplication, and union is like plus. So you can just think of it in that way, although you know that these are not really multiplication, addition, or power. These are the operators that we define over sets. So let me just show you some example. It has been that definition was very abstract. So the first example that you can see here, this is a valid regular expression, and 0, 0, 1. And what does this regular expression represent? This regular expression actually has been created from the concatenation of 0, which is a valid regular expression, right? This is the base, and then it's just like you concatenate to another 0. So this one also is a valid regular expression. What this regular expression represents? It represents one string, which is 0, 0. And it's just like you concatenate this one to another regular expression, which is 1. The whole regular expression is going to represent one string, which is going to be 0, 0, 1. Okay? So any string is going to be a valid regular expression. This is a valid regular expression. You can see that I'm using the operator union and the parentheses, and also I'm actually applying the concatenation here as well. So based on the precedence level that we defined here, the parenthesis is going to have the highest precedence, right? So it's just like this part. Let me actually kill it here. This part is going to represent two strings, 0 and 1, right? This is the union of 0 and 1. Now you are concatenating 0 to that, so it's just like you have another set and you concatenate this set to this set. The result is going to be the set of the strings generated by concatenation there. So 0, 0 and 0, 1. So you can say this is the set of strings represented by this regular expression. So let me just clean up here. The next string is going to be, the next regular expression is 1, 0 star. Remember the precedence level? Closure is going to have the highest precedence. So closure will be applied only over 0, not 1. Okay, so it's just like you have a 1 concatenated to the set of 0 closures. That set of 0 closure is going to be, so 0 closure is actually representing this set of strings. Epsilon, right? 1 0, 2 zeros, and arbitrary number of zeros, in fact. Okay, so you concatenate 1 to epsilon. You concatenate 1 to 0 star. So the result is going to be this set of strings. 1 has been concatenated to epsilon, to 0, to double 0, and to arbitrary number of zeros, in fact. So you can just think about it as the set of all strings that starts with a 1 and followed by arbitrary number of zeros. This one is also a valid regular expression. A star will be applied over 0, then 1 will be actually concatenated to that, then you get the union between this set and this set. Okay, so this part we have already know that this is going to be this one, and you get the union of that with 0, so just we added 0 to that. This is also a valid regular expression. So this one is going to be, arbitrary number of zeros here, arbitrary number of zeros here, and they're just concatenated before and after a 1. So this is going to be the set of all the strings. So here you can see that you can think of it as a regular expression that shows all the strings that has exactly 1, 1, all the binary strings that has exactly 1, 1, right? You are allowing to have arbitrary number of zeros before or after that. So I can actually just say that this is going to be the set of all binary strings which exactly has a single 1. Another regular expression. So here I have parentheses, so it gives the higher precedence to inside the parentheses, so you get the union of 0 and 1, then you apply the closure over that. So what it actually creates, it's going to be the concatenation of, arbitrary concatenation of the strings 0 and 1. So it's going to be all binary strings, in fact. Okay, so this is a very famous regular expression that you will see it everywhere. That if you wanted to give arbitrary binary string, this is going to be represented in this way. So this one, now you can see that it's just like I have arbitrary binary string which started with exactly a 0. So you can say that this is going to represent the set of binary strings that starts with a 0. Okay, so this is the definition of this set of strings represented by this binary, this regular expression. This one, again, this is going to be the set of all binary strings that ends with a 1. Okay, because you have arbitrary binary string which is concatenated to a 1. So this one is everywhere at the end of the binary string. So all binary strings that ends with a 1. How about this one? Here I don't have a closure property. I just have a union here and a union here. So this is going to be the set of all binary strings of length 2. Right? So 1 comes from here and 1 comes from here. So the set of all binary strings of length 2. if I put the closure, apply the closure over all of it, you can see that I used another parenthesis to make sure that this closure will be applied over all of it. So this is going to be the set of all binary strings which are of length even, right? Because in fact inside the main parenthesis here, let me just clean up a little bit here. Inside the parenthesis, the main parenthesis that I have, I am actually allowing any binary strings of length 2. So all possible binary strings of length 2. By applying the closure over that, you are just saying that, okay, all those binary strings of length 2 can be repeated arbitrarily. So this is the result is going to be all binary strings of length even, right? So each time you are actually adding another thing, so it's going to be 2 more tokens will be added. So all binary strings of length even. This one is going to be here. You can see that I'm using that epsilon notation. That means that, okay, so epsilon just shows epsilon. So you have the union of 0 and epsilon, and then you concatenate it to 1. So the result is going to be 2 strings, 0, 1, and 1. This one, again, you have actually 2 parentheses, and the union of 0 and epsilon, the union of 0 and 1, you just need to concatenate all of the these strings to these strings. So the result is going to be 4 strings, epsilon, 0, 1, and 0, 1. Basically, when you concatenate epsilon to any regular expression, this is just like you can actually put it before or after it, concatenate it before or after. In general, when you are concatenating 2 regular expressions, so, RS is different than SR, okay, in general. You can't say that RS is equal to RR. SR, the order in the concatenation is important for us. Unlike the union, that the order is not important for us. S union R or R union S, these are actually equivalent, right? Because the order is not important for us in the union, but in concatenation it is important for us. The only case that the order in the concatenation is not important is where one of the regular expressions is in fact epsilon. So it doesn't matter if you concatenate it before or after. The result is going to be equal to the regular expression R. When you get the union of R and the MT, you can see that this one, MT, is also a valid regular expression. This was a part of the base regular expressions for us. MT just represent the empty string. So the union of any regular expression and MT is going to be that regular expression. The result is the same. But one thing that you should be careful about is the concatenation of a regular expression to empty string. The concatenation of R to an empty regular expression is going to be empty. So it's just like you are multiplying it by 0. Just think about it in that way. So the result is going to be empty set. So let's see a couple of more examples here. We wanted to build a regular expression to represent the following language. All binary strings that has at least 1 0. Okay, so that has at least 1 0. It can have more than that, and it should actually create all binary strings. So if you are writing a regular expression like that, you can think of it as this way, that I need that 0, and I don't know where this 0 is going to happen, right? So I should actually allow arbitrary binary string before and after this. How can I represent arbitrary binary strings? It's going to be 1 union 0 killing closure. 1 union 0 killing closure. So this is going to be a valid regular expression for this string. So I wanted to actually show you that when you are writing a regular expression, the regular expressions are not going to be unique. For one set of strings, you can write many different actual regular expressions for that. Depending on the string. So this one is also a valid binary, a valid regular expression for the same set of strings. You can see that I put arbitrary number of arbitrary binary strings at the beginning, and then say that, okay, put that 0 that you want, and then put arbitrary number of ones at the end. This is going to represent the same set of strings and with this one. You can see that I just actually replaced this one with one closure. You might actually say that, okay, these are different, right? These are different, but at the end, the set of strings that will be represented by this regular expression is exactly the same as the set of strings that will be represented by this one. All those strings that you can represent it here can be represented in some way using this one as well, because you are allowing arbitrary binary string at the beginning, right? And the final 0 that you have in your thing is going to be matched to this one, and if you have more ones, it will be actually matched to this 1 star. So just like that, I can write another regular expression in this way, that I put that arbitrary number of ones at the beginning, and then I put the arbitrary binary string at the end of that. So it's just like, if you think about it about these different three regular expression, this one I am actually saying that, okay, that single 0 that I care about and I wanted that it should be there, it can be anywhere, right? Here you just consider that 0 to be the last 0. Okay, you are not actually allowing more zeros after that, but still you are allowing arbitrary binary strings that has at least 1 0, and you are just emphasizing on the last one. Here you are emphasizing on the first one, but at the end all of them are going to represent the same set of strings, so that this set of string is unique, but the regular expressions are not unique. They are just different representation. All of them are representing this unique set. This is another example that binary strings that has at least 2 zeros. Kind of, this is similar to the previous one. I put those 2 zeros, right? And then I would say that, okay, those 2 zeros can happen anywhere, right? I just want them to happen, but I don't know where they are going to happen. So I put arbitrary binary strings before and after all of these 2 zeros. So just like the previous discussion that I had, I can say that these 2 zeros, I can show them as the final 2 zeros in the binary string. So I can put actually 1 star arbitrary number of ones in between them, and I'm emphasizing on the last 2 zeros, and the rest of zeros will happen at the beginning. Or you can actually emphasize on the first 2 zeros and say that the rest of zeros will happen at the end. Okay, so again, the set of strings is unique. The regular expressions are different, but all of these are representing the same set of strings.